functions. So that's the name of the game in this section. The goals, we want to identify and evaluate functions. That's number 1. Number 2, to find the domain and range of a function. And number 3, to apply definitions having to do with functions. Lots of terminology, in other words. And that's what we'll start with. The first definition, a relation. Well, a very simple way to think of it is a set of ordered pairs. But you can also think of a set of ordered pairs as inputs and outputs. The first coordinate as the input, the second coordinate as the output. Let me give you an example. So R, capital R for relation. You could have the ordered pairs 1, 2. I'm not getting very creative here. 3, 4. 5, 6. I'll separate these ordered pairs by commas as well. And then maybe, how about 1, 8? Is that a set of ordered pairs? Yeah, you got curly brackets around it. You've got a listing of ordered pairs. It's a set of ordered pairs. It's a relation. Now, how can you think of it as inputs and outputs? So this input of 3, the input's always the first coordinate, corresponds to an output of 4. There's one weird input there. Does anybody see a special input that's not like the others? 1. Why is 1 special? There's a 1 there, and there's a 1 there. Those are both inputs, right? They're the same input, really. But there's 2 different outputs for it, isn't there? There's 1 goes to 2, there's an output of 2, and an output of 8. That's problematic. As an example, you could think of your calculator as a function machine. Let's say you want to add 2 numbers together. So you input 1 plus 2. The input is 1 plus 2. There's 2 numbers, a little bit different than what we're talking about here, but not that much. So there's 1 input, the 1 plus 2, the 1 and the 2. You add them together, what should you get? 1 plus 2 is 3. You don't want to get 2 different outputs, do you? That would be problematic if you took 1 plus 2 and got 2 different numbers, right? Well, that's kind of like what's happening with this relation. The input is 1, and we're getting 2 different outputs. We're getting a 2 and an 8. So that can be problematic in certain situations. And so we refine the definition of relation to the definition of function, and we don't allow this kind of thing to happen. We don't allow 2 different outputs. So that's the next definition. So a function is a relation. It's a relation in which no 2 different ordered pairs have the same input or same first coordinate. Remember, first coordinates are inputs. So obviously R is not a function, right? Because you have 2 different ordered pairs with the same input, with the same first coordinate, not a function. Does everybody see why? You could create an arrow relationship just as easily. You could put the inputs on the left. You've got inputs of 1, 3, and 5. You're not going to write down the 1 twice when you do it this way. And then the outputs you could write down, you've got 2, 4, 6, and 8. And then you could indicate the input-output relationship with arrows. 1 goes to 2, and it also goes to 8. 3, there's only 1 arrow coming off the 3. It goes to 4, and 5 goes to 6. So this is just to illustrate that in a relation or a function, you don't need to use ordered pairs to represent it. You can use this sort of arrow relationship. And if you see 2 different arrows coming off 1 input, The input's on the left, the output's on the right. So input's on the left, output's on the right. If you see two different arrows coming out of one input, it's not going to be, that relation is not going to be a function. So that's another way you might conceive of it, or you might see it in your book. Okay? So let's do an example of something that is a function, a set of ordered pairs that is a function. An example as a set of ordered pairs might be, let's call it F. Let's go 1, 2, 3, 4, and 5, 6, and one more. Let's go 7 to 2. First of all, is it a function? Is there any problem here? Yeah, but is that a first coordinate? No. So the definition of a function says nothing about that. A function is a relation. Is it a relation? Is it a set of ordered pairs? Yeah, so it's definitely a relation. It's definitely a set of ordered pairs. A function is a relation in which no two different ordered pairs have the same first coordinate. So scan those ordered pairs. Do you see the same input, the same first coordinate? Nah. So you're good. I put the 2 there just to make you think about it, right? Okay. So this is definitely a function. You scan the ordered pairs. No two different ordered pairs have the same first coordinate. In other words, you don't have an input and a first coordinate going to two different outputs like in the last example. So the domain of a function is a set of all inputs, or first coordinates if you like. And the range is the set of all second coordinates, or outputs. Let's use outputs first since I used inputs first above. So outputs are second coordinate. Okay, so let's do an example here. So that function f from above, I think I said it was 1, 2, 3, 4, 5, 6. And then I think I went 7 back to 2, if I remember right. Not that it matters. So the domain, you could go D for domain. Can you guys tell me, based on definition number 3, what's the domain of that function? So just look at all the first coordinates, all the inputs. There you got it. Yeah. It almost seems like, well, that's too easy. It's got to be a trick question, right? No, it's what it is. So it's 1, 3, 5, and 7. What did I do? Just look at all. That's a horrible curly bracket. Let me try again. What did I do to get that? Just looked at all the first coordinates, right? 1, 3, 5, 7. D stands for domain, and then R stands for range. What's the range? So the range would be 2, 4, 6. Are we gonna write down 2 twice when it sets? No. You're not gonna write down the same entry or same element in the set twice. So just 2, 4, and 6. 2, 4, 6. The domain is the set of all inputs of a function, set of all first coordinates. The range is the set of all outputs, set of all second coordinates.